Okay, on our numeracy journey, some very fundamental things are very necessary to understand. These are findings coming from research. Research, most of the time, we find it just restores our common sense, because our common sense, with the passage of time, it is shrouded in the noise, and we lose the signal. The common remains, then the sense is lost. And insights, they are huge. Instead of I coming with my 10 years of experience or 200 students, we have now 400 million students' data footprint, which we can capitalize on. So the first thing is, maths is a little different from other subjects that we need to understand, so that we interact accordingly and keep it in mind. Number one, there is a critical age which is 11 years. Statistics is that at the age of 11, the child takes a mental decision. I can go with the math, or it's something kind of difficult for me, right? What does it mean for us? It means for us that before the age of 11, we should absolutely not get into hurry or jump to label. Oh, Sadia understood in 3 months these multiplication tables, you are still lagging behind. No, we have to wait. There's a huge variability among students, and it is this age. If we teach properly, obviously the children starts loving it. Maths is a very fun subject, but 11 is the age. Till the time, we should patiently wait and repeat and go back. And as the George Polier says, if a child is not learning the way we are teaching, let's teach the way they can learn. That's very important. Number two is, we forget, and that's natural in our mental process. Maths, forgetting is much faster than any other subject. It goes very steep. If there is a gap of, let's say, a week, 10 days, and the child comes back to us, actually with hardly 10 to 15% of what we last taught. So if after class 3, we are starting off with a little bit of a gap, the class 4, and the first topic of the class 4 comes, if I do not repeat the previous one, I will be going with the assumption that he remembers. This assumption is totally false. The effect is, since we just start off, they lose their confidence. They feel like till the previous I was understanding, but now the sort of difficult things have started coming in. Most of our children resign in this process, when we just jump to the next topic without brushing up the new topic, right? And one specific thing about the maths is that in maths, the concept connections are very hierarchical. Obviously, if they don't know addition, we can't switch over to multiplication. These things in social sciences are not that hierarchical. Even in the science, we can teach light first before we can learn forces. But in maths, it's extremely hierarchical. So that thing that what comes before it must be understood from the research and from the concept connections. For example, if we start teaching multiplication tables, and we have not done enough exercise on doubling and halving, children will take much more time in making sense and even memorizing the tables. If we have spent a good time on the doubling and halving, they'll run faster. The same journey will be in maybe 20 to 30% of the time, which otherwise they will take a lot of time. So that's very important to understand. One more thing in which maths, and in fact others also, it works in other subjects also, is we should never start with symbols. Children learn by concrete, small children particularly. Then we should move over to pictures, And finally, we can transition to symbols. And obviously, the symbols are extremely powerful. The abstract math we will later see is much more powerful than the concrete math. But the concrete is the point to start with. If my child has seen this thing as a cube, later if I remove the cube and make its photo, it's very easy for them to make sense out of it. Otherwise, if he hasn't touched it and I see how many sides it has, you can't mentally manipulate so easily, right? And there's a lot of sense on it, in it, and it's coming from the maths gurus who have spent their lives in it. And one last lesson is belief. If the child has lost his or her belief that I can do, it's extremely important. I will just give you one instance where, quoted by John Hattie, 8th class girl, she was doing a maths and her father passed and say, daughter, what are you doing? I'm doing proportions. Oh, this was very, really, I didn't like it when I was, okay. That one sentence, and after that child, her score in that subject math drooped like this. Because she thought if he couldn't learn it, maybe the subject in itself is difficult. No subject in itself is difficult. It's just the matter of interest if we can develop and all that. That's all. This is the lessons of today. But one specific thing which George Polya always says is very interesting. That is, it is the cheapest science. Unlike physics and chemistry, it doesn't require expensive equipment. You can just start anything common around you and start playing with it, and you can do logics with it, and you can do geography with it, and as you can do patterns with it and anything, and it starts working. And children would love it if we do it properly. Thank you very much.